Okay guys, you asked for a little refresher on naming organic compounds, so here goes. Naming organic compounds. This is the screenshot from where I have listed all of the organic compounds on the board in our room. I will go through 1 through 10. I will not be going through 11 or 12. So, first we have alkanes. We are looking for a carbon-carbon single bond, and we don't use a prefix, and that suffix would be ane. Then with cycloalkanes, we have a ring, and so we use a prefix cyclo, and we keep the same suffix alkane because we still have just carbon-carbon single bonds. Alkenes, now we add a carbon-carbon double bond. We don't have a prefix, and now we change the ending from ane to ene. Then if we have a cycloalkane, we have a ring, and we also have a carbon-carbon double bond, so we add the prefix cyclo, and then we add the ending ene. And of course we have to number the cycloalkane or the alkene so that that double bond has the lowest number possible, starting at whatever end is closest to the double bond. And for a cycloalkane, we have to give the double bond carbons 1 and 2. So then we have alkyne, that's a carbon to carbon triple bond, and we give it YNE, and again we're going to number that so that the triple bond gets the lowest number possible. We start at the end closest to the triple bond. 6 is our first one that has an alcohol, has a non-carbon atom in the structure, and that's where we have a carbon to oxygen to hydrogen bond, and we change the final E of alkane or alkene to OL. Then ether is where we have that oxygen actually in the carbon backbone. You'll have a carbon to oxygen to carbon bond, and then we name the two pieces on either side of the oxygen, and then we add the word ether. Finally, now we have an aldehyde where we have a carbon to oxygen double bond, but it has to be at the end of the chain. It would be given carbon number 1. We don't number it, but we change the final E of our alkane name to Al. Then as a ketone, we have that same bond, a carbon oxygen double bond, but it's anywhere in the middle of the structure. We would need a number for this one. You have to tell me where that oxygen carbon double bond is, just like you have to tell me where the carbon carbon double bond is, where you have to tell me where the alcohol is. And so then we would change the final E of our alkane name to ONE. And then carboxylic acid, we have a carbon in our chain that is double bonded to one oxygen and single bonded to an OH group as well. And we change the final E of our longest chain to oic, and we add acid. And again, that carbon would be carbon number 1, and everything will be referenced to that. So I've gone through the kind of basics. Now I'm going to go to drawing a few structures for you so you can see what it looks like. And again, I have copied for you the picture from, sorry about that, copied the picture from our classroom for you, and so you will be able to follow along, hopefully. If you haven't written that down, I would suggest you do so. And so you're going to find out real quickly why I don't draw these by hand for our quizzes and such, because they're just harder to read. So if I have something like this, I would have 1, 2, 3, 4, 5 carbons, and so that would just be pentane. If, however, and let me just erase part of this, if I erase this, and let's say I put a double bond in, and let's say I put it here, I've got a double bond between carbons 2 and 3, so now it would be 2-pentene. If I were to add a group off of here, and let's say a group here, now my name It's still 2-pentene, but I need a couple other things. I have a methyl group on 2 and a methyl group on 4, so it would be 2,4-dimethyl, and then 2-pentene. So if we have a ring and we put some groups off of there, now we're going to have to number starting here with 1 and 2, so that 1 and 2 have to be my ring. And then I want the methyl groups to have the lowest numbers possible. So I went around in that way on purpose so that I could have the lowest numbers for the methyl groups and 1, 2 for my double bond. So this would be 3, 4 dimethyl 1, and you don't need that 1, but you can put it in cyclohexene. Since I have that double bond. So how about a triple bond? So let's just do, put a triple bond in there, put a methyl group there, put one there. Okay, so let's number this. We have to start so that the triple bond gets the lowest number possible. Here, let's make this a little longer so it's not symmetric. And we would have to start numbering from the left to the right. And so this would be 1, 2, 3, 4, 5, 6, 7. And so we're going to have methyl groups on 2 and 5. So it's going to be 2, 5 dimethyl, and then 3, and then hep, and then we change the ending to YNE. And so that would be like number 5 in our picture from class. How about we do an alcohol next, okay? Alcohol it is. Oh, let's do a cyclic alcohol. So let's put our OH there, we'll put a methyl group there, one there, and one there. So the alcohol has to be 1. So this is going to be 1, 2, 3, 4, 5, and 6. I have 3 methyl groups there on carbons 2, 3, and 5. Again, I have to number so that the alcohol is number 1, but everybody else gets the smallest number possible. Since I have 3 methyl groups, it's going to be tri-methyl. And then it's going to be 1, and you don't need that. It would be hexane, but hexanol because we have that OH. So the OH refers to this, is the OL, and then the 3 methyl groups. So let's do an ether. An ether has an oxygen in our longest chain. And it doesn't matter how long I make these. This one's 1, 2, 3 carbons. This one's 1, 2, 3, 4 carbons. This right here is a bond between oxygen and the 2 carbons, and so it doesn't count as one of my numbers. And so to name this side would be propyl, this side would be butyl. So it'd be butyl, propyl, ether. And so pretty simple. Let's go on to the next group, which is aldehyde. Aldehyde, we have a oxygen carbon double bond at the end, so we have to number from here, and we have 4 carbons long, so that would be butane, except for with this functional group we have to make it into an aldehyde, and so this would be butanal, and you don't need a number because it has to be at carbon 1. How about a ketone? We would need a double bonded oxygen somewhere in the middle. Let's put some methyl groups on here. Well, let's make this one an ethyl. We've done all methyls. So I have to make it so that the carbon, oxygen, carbon, so this one here has the lowest number possible. And so I would start here with 1, 2, 3, 4, 5, and 6. And so I have an ethyl on 4, a methyl on 5. So 4 ethyl, 5 methyl. And I do need a number for that oxygen carbon double bond to know where on my chain to put it. It could be on 2, it could be on 3, or it could be on, I guess, just 2 or 3. And so this would be 3, and then hexane, and then we change the final E to O-N-E, hexanone. We have a carboxylic acid is the last one to do. So now we have our longest chain. We put a double bond oxygen and an OH on the same carbon. And that's bonded there. And that's bonded there. You can see why we don't do this. And so now how do I number this? I start here with 1, 2, 3, 4, 5, and 6. And so I have an ethyl on 3 and a methyl on 2 and 4. And so it's going to be 3 ethyl, 2, 4 dash dimethyl. And then my longest chain is 6 hexane, and I change the final E to OIC and then add the word acid. Okay, so that goes through all of the groups that you have to be able to name, 1 through 10. Hopefully, between the PowerPoint and these examples, that's enough to get you through. If you have additional questions, you should probably stop by and see me in the morning, because you will be having another quiz tomorrow. Hopefully you will do better. And remember, we will keep having these until we get to where we have 90% get a 7 or better.